Now, as we said before, the entropy of the universe has to be positive in order for a process to occur. If we want to know if a process is spontaneous or not, when we have a system that can interact with its surroundings, we can use what's called the Gibbs energy. And the Gibbs energy tells us how much of the energy in a process is available to do work. So we know that we can't get 100% efficiency taking energy or heat and converting it to work. And the Gibbs energy tells us how much we can actually get, how much work we can actually get out of a process. And it turns out that if the Gibbs energy is given the symbol G, capital G, and we can look at changes in the Gibbs free energy. So we can look at delta G for a process. And the equation for the Gibbs energy that we'll use in this class is going to be equal to the enthalpy change for a process minus the temperature times the entropy change for a process. So this would be at constant temperature and pressure. So at constant pressure, heat is enthalpy, and we have constant temperature. There's no change here. Temperature is just the value. So we have the change in the enthalpy and a change in the entropy. This is constant T, temperature, and pressure. So we can tell if a process is spontaneous because, now in this case, delta G will be negative for a spontaneous process, and delta G will be positive for a non-spontaneous process. So remember, delta S for the universe for a process has to be positive. And delta G can tell us if a specific process is spontaneous or not. So just like we could tell with intuition that me stepping off the top of a building and falling is spontaneous, or that temperature equilibration is spontaneous, we can use delta G as a predictor for more complicated processes to see if something's spontaneous or not. So instead of having to add up delta S of the system plus delta S of the surroundings, we can use delta G, and we're going to use delta S of the system, delta H of the system. So this is of the system. And we can use delta G to tell us if a process is not spontaneous or it is spontaneous. Now delta G just tells us if something can occur if it's spontaneous. Say we want to build a building, and so we have all these materials, and they're disorganized or all over the place, and so now we have materials trucked into a particular place. We start building a building, and we have the carpenters and the cement guys and the bricklayers and everything. So now we create this nice building. We have ordered all these materials. So that's an increase in order. So that would be a decrease in entropy. So we build a building. So we have this nice building here, and we have decreased delta S for this process is negative. We have ordered all these materials, all our building materials here. We had sand, concrete, mortar, all this stuff, nails, forms, and we have ordered all these things into a building. So we have created order, so entropy has decreased. But this process occurred, even though it's not spontaneous. So how come the process occurred, the delta S of the universe is positive. So the delta S of our system building the building is negative, but delta S of the universe is positive. So where did that other positive part of the entropy come into? Well, the entropy of the surroundings. We expended a lot of work to build this building. We had a lot of heavy equipment. It was burning diesel fuel, and all that fuel burning, all this heat was dumped into the environment to build this building. So all the workers produced body heat, which was dumped into the surroundings, and all the heavy equipment produced a lot of heat, which was dumped into the surroundings. So that heat went into the surroundings and increased the entropy of the surroundings more than the decrease of the entropy of the building. So therefore, the entropy of the universe has increased. So we can cause a local process that's not spontaneous to occur, but delta S of the universe has to be positive. We have to dump enough heat into the surroundings to cause the entropy of the surroundings to increase to offset the entropy of our process or system.